Alcohol is an anesthetic, so it can decrease pain. In fact, patients with chronic pain use alcohol for self-medication. However, when a patient stops alcohol consumption and goes through withdrawal, their pain can come back at even greater levels than initially experienced. This increased pain can drive a patient to consume more alcohol, contributing to the persistence of alcoholism. The mechanisms behind this feed-forward process are unknown. This study explores the relationship between pain and alcohol consumption using Drosophila melanogaster, the common fruit fly. If we can model what we see in humans with flies, we can use these tiny organisms to ask more detailed questions about how alcohol affects pain. Do ethanol consumption and its withdrawal affect pain sensitivity in Drosophila larvae? We hypothesized that ethanol exposure would decrease pain, while ethanol withdrawal would increase pain. We measured pain sensitivity in larvae by poking them with a thin filament called a von Frey hair and measuring the frequency at which the animals perform a pain-like rolling motion. The more often the animals respond, the more pain they are in. We then exposed larvae to different concentrations of alcohol mixed into their food to test whether ethanol exposure changed their sensitivity to that von Frey hair. Responses before withdrawal were not significantly different with respect to ethanol concentration. However, responses after withdrawal were significant for the larvae in the 5% and 10% group. The larvae exposed to 0% and 20% did not see a significant difference in response rates. The biggest weakness in this experiment is the low sample size, and the fact that although we can measure this pain-like behavior, we can't be certain the larvae actually feel pain. We found that, similar to humans, ethanol withdrawal did increase pain sensitivity in the larvae, suggesting they could be used as an animal model to study this phenomenon. We did not, however, find that alcohol exposure itself relieved pain in larvae. Overall, it can be concluded that fruit flies are subject to the same physiological effects as humans while under the influence of ethanol. In the future, we would like to test the effects of long-term exposure to ethanol and expand into mice, which may better represent human physiology. Although alcohol can moderately ease pain, in the long run, it can increase pain sensitivity. The intended audience of this video is other science-based folks and possibly the layperson. This study looked at effects of alcohol and withdrawal and pain sensitivity, and also the importance of working together. This is important because it's common for people who suffer from chronic pain to self-medicate using alcohol, which may also lead to alcoholism, and if they withdraw, they may experience increased pain sensitivity.